All right, guys, we're going to attempt this. I have to do it the old school way with my phone, so bear with me. I hope that this shows up normal on your computer and you don't have to like turn your head sideways or anything or upside down. But you got to do what you got to do. All right, so on this one, on this problem, they want you to graph the transformation. So remember, when we have an absolute value that so when you have a transformation, when you have an absolute value, remember it's going to be a V. It's going to be shaped like a V, whether it's tall and skinny V, short and fat V, upside down V, whatever. An absolute value is going to be shaped like a V. So in this case, because we do have a negative in front, that means it's going to be an upside down V. Okay, this one right here. All right. And so because there are no numbers inside the absolute value sign or outside the absolute value sign, that tells us that our vertex is still going to be at 0, 0. Okay? But instead of going up like this, now it's going to go down. So down 1 over 1 on both sides, down 2 over 2, and we make a V, just like that. So that one's pretty simple. Okay? All right, number 2, which might be a little more difficult here. Let's see if we can get this one. All right, so number 2 is just like the parent function. Remember, the parent function of an absolute value is going to be this, right? So the only thing we have different here is this 2 in front, and that 2 is your slope. So that means instead of going up 1 over 1, you're going to now go up 2 over 1. So your vertex, again, since there's nothing in here and there's nothing out here, our vertex is still at 0, 0, right? So then, instead of going up 1 over 1, like that, you're going to go up 2 over 1, and up 2 over 1 on both sides. And so you're going to be, and then up 2 more, and over another one, and up 2 more, and over another one. And so your V is going to be a little bit taller and skinnier. You can kind of tell between these two. See how even though it's upside down, it's kind of short and fat, and this one's a little bit taller and skinny. Not much of a difference because it's only 2 times, but there is a little bit of a difference. And oh, I forgot to do domain and range. Let's go back. All right, so the domain, if you remember, domain on absolute value is always going to be all real numbers, right? And so again, over here on this one is also going to be all real numbers. So again, I apologize for this being shaky, and I apologize for it being all over the place, but my computer fried, it literally fried, and so I have a different computer that doesn't have a touch screen where I can write on the screen and record it. So we're doing it again the old-fashioned way. All right, so the range on this one is your y values, and if you look, none of these y values up here are being used, right? Okay, so our range is going to be from 0 and on down because it keeps on going, right? These keep on going. So it's going to be 0, and it includes 0. So it's going to be a box or a bracket. And then it goes all the way to negative infinity. Okay? And then over here, it's going to be 0 again, but this time we're going up. So it's 0 and positive infinity. Oops, there you go. Sorry. Okay, this one, nothing changes with the slope, right? But we do have this little guy here in the middle, which will affect our vertex. Remember, our vertex on a normal parent function, when it's just the absolute value of x, is going to be 0, 0, right? But this one, because we have this 4 here, it's going to shift us to the left, actually. Okay, it looks like because it's a positive 4, you'd think you'd shift to the right, but you don't because you go, what makes this 0 inside here, right? And negative 4 would make this 0. So we go to negative 4. 1, 2, 3, 4, and that is our vertex. And since our slope is the same, we just go up 1 over 1, up 1 over 1, just like that. Sorry. There we go. Like that. And voila. Okay. And again, our domain, all real numbers. And our range, Even though it's shifted to the left, it's still on the 0 on the x-axis. So it's still going to be 0 and everything above it, right? Because again, there's nothing going on down here. Nothing. So that means it's going to be 0, oops, bracket, 0 to positive infinity. Okay? Over here, we have a negative, so that means we're going to flip it upside down, right? So we're going to have upside down v. And then we have a positive 6 on the outside. Oh, well, and we have a 2 with our negative, which means it's going to make it taller and skinnier. And then our 6 is going to shift it, because it's outside the bracket, or outside the absolute value, that's going to shift us up 6, because it's a positive 6. So our vertex is going to be at 0, and then positive 6. 1, 2, 3, 4, 5, 6. Right there. And then now, it's going to open downward, and it's going to be down 2 over 1. Down 2 over 1. Okay? And then down 2 more over 1. Down 2 more over. There we go. So it's going to be something like this. Okay? All right. And this one, our domain, again, is all real numbers. And our range this time is going to be at this point and everything below it, because they're continuing down, right? Nothing's happening up in this area. So it's positive 6, and it does include that, so it's a bracket, positive 6 to negative infinity.